Hello student, welcome to Praveen Patil College of Diploma Engineering and Technology Bhandarist. Our department Humanity and Science course Basic Mathematics course code 22103. Myself again Smita Shekhar Kamble. Today's lecture is obviously depend on Matrices chapter unit 1 chapter number 3. And our today's topic of the lecture that is very important, that is the application of each and every method and topic concerned with the matrix, that is matrix inversion method. We have to summarize the method of the 2 by 2 matrix inversion method. What is that? Format the simultaneous equation for the variable x and y. Ax plus by is equal to m. Cx plus dy is equal to n. Rewrite them in a matrix form. That means we have to take A, B, C, D as a matrix, that is coefficient of x and y in each system of equation. Then we have to compare the constant m and n to the right hand side and obviously x and y the column. If we multiply row with column, we have to define this system of equation. That means we have to solve the system in a matrix. Find the inverse of 2 by 2 matrix. That means we know that the inverse of any 2 by 2 matrix is given by 1 upon determinant of A into adjoint of A. We know that 1 upon determinant of A, that means AD minus BC, that is determinant of A. Next, we have to find the adjoint of this given matrix, that is AB minus, that is ABCD. That means we have to interchange AD, that is instead of A there is D, instead of D there is A. And we have to change the sign of B and C. That's why minus B minus C. So we have the A inverse is 1 upon AD minus BC, D minus B minus C, A. You have to must remind that system of 2 by 2 inverse of the matrix. That is 1 upon AD minus BC, D minus B minus C, A. Then compare and put the values. We derive the A inverse there. To solve the variables x and y, multiply the right hand side of the equation by the inverse. That means we have to multiply m and n constant to the inverse of the matrix. That is 1 upon AD minus BC, D minus B minus C into A into m and m, that is row with column. Same procedure we have to apply for the 3 by 3 matrix. What is it applicable? Let us check by the step by step. Matrix inversion method for 3 by 3 order. Step number 1. Verify the given system in the form of A11x plus B12y plus C13z is equal to D1. A21x plus B22y plus C23z equal to D2. A31x plus B32y plus C33z is equal to D3. Now step number 2, we have to rewrite the three system of this equation format in a matrix form A11, A12, A13, A21, A22, A23, A31, A32, A33. That means this system of equation have three variables x, y, z and their coefficient allotted in a matrix form. How many constants are given in this system of equation? D1, D2, D3. We have to keep that constant for the final product of A inverse. Step number 2 we have to cover. Step number 3, that is obviously we have to find the adjoint of such matrix. We have to take Cij, that is cofactor C11, C12, C13, C21, C22, C23, C31, C32, C33. Now step number 4, that is we have to take the transpose of this constant and we have to must change the sign of the diagonal element after changing the transpose. We have to discuss in 3 by 3 cofactor method of that adjoint format. Cij transpose is equal to ADJ, that is the main format. Step number 7, that is we have to consider Ax is equal to C, that means x is equal to A inverse into C. We have to find the xyz by given A inverse. Let us apply this procedure to the new system of equation in a given example. We have to must check using matrix inversion method solve the equation. We have to must check three equation must be given with three variables with three constant. Yes, 3x plus y plus 2z is equal to 3. 2x minus 3y minus z equal to minus 3, x plus 2y plus z equal to 4. We have to first check that is x, y, z, three variables are linear in all the system of equation. Then we have to compare their coefficient in a matrix form, and the constant are 3, minus 3 and 4. So A is equal to 3, 1, 2. If no constant is available, we have to consider that its coefficient is 1. Always remind that. So that's why we have to format the 3, 1, 2, 2 minus 3 minus 1, 1, 2, 1. That is A matrix. X is equal to what? X, Y, Z. Three variables in a column format. C means a constant column, that is 3 minus 3, 4. 3 minus 3, 4. So we have to rewrite this. First target is we have to find the A inverse of this given system of the matrix of the order 3 by 3. We have the formula A inverse is equal to 1 upon determinant of A into adjoint of A. For adjoint, we have to first know C11, C12, C13, C21, C22, C23, C31, C32 and C33. It is easy. We have to find C11. First row, first column, skip. What is remaining? Minus 3, minus 1, 2, 1. So that's why we have to write minus 3, minus 1, 2, 1. Minus 3 into 1, minus 3, 2 into minus 1. That is the minus minus plus 2. Final answer is minus 3 plus 2 minus 1. Next, obviously C12. For C12, first row, second column we have to skip. What is remaining? The cofactor 2 minus 1, 1, 1. So I should write here 2 minus 1, 1, 1. 2 into 1, 2. 1 into minus 1, minus 1. But minus minus become plus. So what is the 2 plus 1 is equal to 3. Next our C13. That means the first row, third column we have to skip. 2 minus 3, 1, 2. 2 minus 3, 1, 2. Then determinant of this 2 into 2, 4. Minus is there, but 1 into minus 3 is minus 3. But that's why minus 3 minus is plus 3. 4 plus 3 equal to 7. Next, obviously, we cover the first row, each and every cofactor C11, C12, C13. Now, next one is what? C21. Yes, right. C21 means second row, first column. Second row, first column is skipping. 1, 2, 2, 1. 1, 2, 2, 1. So we have to take the determinant of this. 1 into 1, 1. Minus remain as the same. 2 into 2, 4. 1 minus 4, minus 3. Now the second cofactor for the second row is what? C22. Yes, we have to skip the second row, second column. Second row, second column. What is remaining? 3, 2, 1, 1. That's why 3, 2, 1, 1. We have to take the determinant. 3 into 1, 3. Minus 1 into 2, 2. 3 minus 2, 1. Next, C23 means second row, third column. Second row, third column. 3, 1, 1, 2. 3, 1, 1, 2. 3 2s are 6. Minus 1 into 1, 1. 6 minus 1, 5. So we cover C23. That is C21, C22, C23. Now we compare the second row also. Now our target is third row's element cofactor. That is obviously C31. C31 means third row, first column. Third row, first column we have to skip. What is remaining? 1, 2, minus 3, minus 1. 1, 2, minus 3, minus 1. We have to take the determinant. Minus 1 into 1, minus 1, minus remain as the same. Minus 3 into 2, minus minus plus 6. Plus 6 minus 1, 5. Now C32, third row, second column. Third row, second column. 3, 2, 2, minus 1. So 3, 2, 2, minus 1. Minus 1 into 3, minus 3. Minus remain as the same. 2 2s are 4. Minus 3, minus 4, minus 7. Now our last but not least, that is C33. That is third row, third column. 3, 1, 2, minus 3. 3, 1, 2, minus 3. Minus 3 into 3, minus 9. Minus remain as the same. 2 into 1, obviously, minus 2. Minus 9, minus 2, minus 11. So we define C11, C12, C13, C21, C22, C23, C31, C32 and C33. Now we have to allot in Cij format. C11 is minus 1, C12 3, C13 7, C21 minus 3, C22 C23 is 5, C31 is 5, C32 is 7 and C 3 3 is minus 11. So we have to change the sign of this diagonal element. That is what? 3 minus 3 goes to minus 3, minus 3 goes to plus, 7 goes to minus 7 and 5 goes to minus 5, because these cofactors have negative combination. That is 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 2 is 5 and 2 plus 3 is 5. That's why odd combination sign will be always changed. Now we have to take the transpose of these cofactors. That means rows converted into column. That means minus 1. First row is minus 1, minus 3, 7 converted into first column. That is minus 1, minus 3, 7. Second row 3, 1, minus 5. Obviously 3, 1, minus 5. And the last row 5, minus 7, minus 11. 5, 7, minus 11. Now Cij, by interchanging the signs, we have to interchange rows into column. That is called the Cij transpose. So we have derived now adjoint of A. Now we have to first find the determinant of given matrix. That is 3, 1, 2, 2 minus 3 minus 1, 1, 2, 1 is our determinant. So in determinant value, that is easy. First row we have to skip first row, first column skipping. Minus 3 into 1, it is minus 3. Minus is middle, but 2 into minus 1 is minus, minus plus 2. Now first row, second column, that is 2 into 1, 2, and 1 into minus 1, minus, minus plus 1, and middle is always negative because C12 is always negative. Next, first row, last column, that means 2 2s are 4, minus remain as the same, 1 into minus 3 plus 3. So we derive minus 3 plus 2 is what? Minus 1. Minus 1 into 3, minus 3. 2 plus 1 is 3, minus 1. So it is minus 3, minus 3. And 4 3 is, it is the obviously 7 into 2, 14. So we derive the determinant of 3 by 3 order matrix is 8. So determinant of A is equal to 8. Now we have to consider the formula. A1 inverse is equal to 1 upon determinant of A into adjoint of A. So A inverse is remains same, 1 upon 8. So we have to find the adjoint of A just now. We have to write here. Next step is what? We have to define the adjoint of with A up to this. So I rewrite this step once again. And I put the values in this format. So I have X into A inverse into C. Means what? A inverse remain as the same. C is the constant given to the system of given equation 3 minus 3, 4. So we have to write here 3 minus 3, 4. 1 upon 8 I keep as the same, that is scalar. First row, first column. Minus 1 into 3, minus 3. 3 into minus 3, minus 9. Plus 5 into 4, plus 2, 20. Now second row, first column. Minus 3 into 3, minus 9. Plus 1 into minus 3, minus 3. Plus 7 into 4, plus 28. Now last row, that is first column. 7 into 3, plus 21. Minus 5 into minus 3, plus 15. But minus 11 into plus 4, minus 44. Simplifying, minus 3 minus 9. So it is minus 12 plus 20 plus 8. Minus 9 minus 3, again minus 12 plus 28, it is 16. 21 plus 15, that is obviously 36 minus 44, it is minus 8. Because here bigger sign is minus 44. So we divide the 8 to each term. Yes, it is the multiple of the 8. 8 upon 8 is 1. 16 upon 8 is 2. But minus 8 upon 8 is the minus 1. If we put the values of x equal to 1, y is equal to 2 and z equal to minus 1 in the given system of equation, we derive the final answer. We derive the x equal to, what is the value? 1. 3 into 1, 3. Plus y value is what? It is 3. It is obviously what is the given? That is, we derive the y is equal to 2. So we have to substitute y is equal to 2 here. So 3 plus 2 is 5. But z is minus 1. So 5 minus 2 is 3. So both the values of the given system of equations are right. X equal to 1, y is equal to 2 and z equal to minus 1. So today's lecture is obviously based on the adjoint of A matrix inversion method.